Alright, I'm interested in solving this quadratic equation by factoring or using the zero factor principle. Here I have a quadratic equation in standard form. Remember, standard form is the value ax squared plus bx plus c equals 0. So I'm in standard form, and that's my a value in this case is invisible 1, and my b value is 5, and my c value is 6. Whenever I'm doing solve by factoring, if I have a value of 1, I'm in good shape. And what I'm really looking to do is, this is a trinomial because I got 3 terms. I'm looking to put this trinomial into 2 binomial terms, and what that'll allow me to do is allow me to get rid of the x squared and get me some factors that I'm able to solve with. The trick to doing this is basically just rewriting this equation. I know the only way I can get to an x squared is if my first value in my two binomials is x, because x times x gives me the x squared. That's the only way I can get to there. Now what I do is, the trick is I look at my back term. My back term, and my c value in this case is 6. And I want to write down all the possible factors of 6. So I can have 6 times 1, I can have negative 6 times a negative 1, I can have 2 times 3, and I can have a negative 2 times a negative 3. All these values, when I multiply together, give me the value of 6. But what I'm really interested in is looking for the values when multiplied together gives me the value of 6, but when I add them together, gives me my b term. And then in all these combinations, because you want to make sure you keep the sign attached with it, in all these situations I have a positive 5. The only 2 possible factors of 6 that when added together give you positive 5 is the positive 2 and the positive 3. So those end up being my factors in this case. 2 and 3 end up being my factors. And just to double check, when I rework this out, x times x gives me my x squared, and then x times my 2 gives me a positive 2x, 3 times an x gives me a positive 3x, and obviously 3 times a 2, when I do my following, it gives me the positive 6. And when I combine like terms, I get back to my original trinomial. So indeed, x plus 3 and x plus 2 are factors of my original quadratic equation. Why this is useful is now that when I get to my original, back to my factors, I can use my zero factor principle to help me solve this equation. What I mean by that is, it's saying if you read this equation, x plus 3 times the quantity x plus 2 equals 0. Well, the only way that I can have any result, any numbers multiplied together to give me a result of 0 is if one of these parts equals 0. You take any number, if this factor, this part in here, this equation equals 0, they'll make that a true statement. Or if this part of the equation equals 0, when I multiply, it doesn't matter what that value is, but any number multiplied by 0, it will end up being 0. So the way I solve this is I take my x plus 3 and set it equal to 0. Or the other possibility is this part, the x plus 2 has to equal 0. And I go through and solve. Obviously the way I solve this is isolate my variable, and I get a value of x equals negative 3. Or again, I'll solve on the other side, I get a value of x equals negative 2. And you can always check by taking that value of negative 3 and negative 2, plug it back into the original equation, and you will get a true statement where 0 equals 0. So again, that's how we solve. Basically, we're looking to take a trinomial quadratic equation, put it into 2 binomials with factors, and then set them equal to 0, and then we're able to solve using the zero factor principle for this quadratic equation.